Okay, we're working on the related rates worksheet. The first problem says if x plus y equals x squared and dx dt is equal to 2, find dy dt when x equals 1. And I love this problem because it's so clear and there's no word problem associated with it, but it shows you everything you do when you do a related rate problem. First, you see that you have a function that has no t's in it, right? No time or anything, so there's no rates. They give you the rate that x is changing according to time as 2, and they want you to find the rate y is changing according to time when x is 1. So this is straightforward implicit differentiation. And I'm going to do it in dy dt, dx dt format so you can see. So the derivative of the first with respect to t would be the derivative of x with respect to t is just 1 times dx dt. You would say this was x prime. And then plus dy dt. Okay, because neither one, x or y, we're taking the derivative with respect to t, right? And there isn't. So that's why you have to still use dx dt and dy dt. Equals 2x dx dt. Now they give us what dx dt is, so that would be 2 after I have now taken the derivatives, plus dy dt equals 2, and they want to know when x is 1, so this whole when, remember, is at the end when x equals 1. So 2 times 1, and then dx dt again was 2. So we have 2 plus dy dt equals 4, or dy dt equals 2. So there you go. There's number 1. Okay, going to number 3, we have another equation. They want you to find dx dt at a certain time when these are 2, when y is 2, when y is 1, it's supposed to be 1. Glad I saw that. When y is 1 and x is 2. So we do the same thing we did with the last problem. This would be 2x dx dt plus, now we have a product rule, this would be 3, derivative of the first, dx dt, y, plus 3x dy dt, plus 2y dy dt equals, and the derivative of 11 is 0. So we want dx dt, but we have x and y, so we can solve for dx dt, I guess, bring that out. So we have dx dt, and then it's 2 times, and x at this point is going to be 2, plus 3y, which is, I'm on this part now, 3y, which is 3 times 1, and that is equal to negative 3 times x, which is 2, dy dt is 2, minus 2y, that'd be 1, and dy dt, which is 2. All right, I hope I have that. So dx dt is equal to, on the top here, we would have negative 12 minus 4 over this part right here, which is 4 plus 3. So dx dt is equal to negative 16 over 7, and that's correct.